Good day everyone. I am Engineer Freedom Carodan. So, hindi ko na kailangan siguro ng intro sa video na to. Ayun, let's start na agad para hindi maubos yung oras natin. Okay? So, for our lecture for today, I'm going to discuss in geotechnical engineering, specifically pile capacity. So, ayan, let's start. So, na-discuss naman na siguro natin yung foundation, di ba? And the types of foundation. Since meron tayong two types of foundation. We have the shallow foundation and we have the deep foundation. So, sa previous topic natin, we have discussed all about the bearing capacity of shallow foundations. Specifically, the rectangular footing, strip footing, and circular footing, and also square footing. So dito naman sa lecture na to, I'm going to discuss the bearing capacity of piles. So under na siya sa deep foundation. So sa deep foundation, we have the embankment depth over the base of the footing must be greater than 1. Okay? So, yun yung basihan nyo, that the depth of the footing or the depth of the embankment over the base of the footing must be greater than 1. So, pag shallow naman, it must be less than or equal to 1. Okay? So, ano nga ba ulit yung deep foundation at bakit siya ginagamit? So, when foundation soils are problematic, such as having low bearing capacity, being highly compressive, having high swelling, shrinking potential, and etc. Shallow foundations cannot be effectively used. In such situations, going for deep foundations, pile, pier, drilled, shaft, caisson, etc. Basic differences between these deep foundation types are their diameters and the installation techniques. All of these are inserted into the ground to a certain sufficient depth and supported partially by skin resistance around the perimeter. So, simple lang naman yung ibig sabihin yan. Okay? So, kung meron naman tayong minimal na structural loads, kunwari residential house lang, so we can use shallow foundation lang. Wherein, meron tayong example na weak soil sa baba ng ating bahay. So, we can use shallow foundation lang since minimal lang naman yung structural load natin. So, kapag naman meron tayong high-rise buildings naman na and we have bridges, doon na tayo gagamit ng deep foundation. Since kapag yung ating foundation ay nasa weak soil lang, may tendency siya na mag-fail. Okay? So, yung use ng ating deep foundation or ang ating piles is to transfer the load from this transfer the load from these structures to the hard strata or the hard stratum. Okay? So, ano nga ba yung mga piles na to? So, pile is a structural members of small cross-sectional area with reasonable length driven down into the ground. This type of foundation is intended to transmit structural loads through the upper zone of poor soil to a depth where the earth is capable of providing the desired support. So, yun yung tinatawag nating hard soil or hard strata. This type of foundation is utilized where it is necessary to provide resistance to uplift or where is possible loss of the ground or erosion due to flowing water. Okay? So, pile foundations may be classified based on materials used. So, yung pile foundation can be concrete piles, steel piles, and timber piles. And so, the ultimate bearing capacity of a pile is the maximum load which it can carry without failure or excessive settlement of the ground. So, the bearing capacity of a pile depends primarily on three factors as given below. Number 1 is the type of soil through which pile is embedded. Number 2 is the method of pile installation. And number 3 is the pile dimension, the cross-section and the length of the pile. So, yan. So, we proceed to the types of pile foundations based on structural behavior. So, meron tayong dalawa dyan. So, the number 1 is the end-bearing piles. It transfers loads from the weaker soil to the strong layer of soil. Okay? So since itong structural loads na to ay merong binibigay na bearing force, of course magre-react yung ating, so subukan nating i-represent. So example, meron tayong structure dito, okay? So gagamit tayo ng end bearing pile. Ayan. Pagpasensya nyo na. So andito yung hard strata natin. Andito yung weak soil. So ito na ibig sabihin na pag end bearing piles, yung ating piles ay nakapatong sa ating hard strata. So of course, galing sa ating structure, meron tayong tinatawag na bearing force. Okay? Force na nanggagaling dyan. And then, of course, meron tayo magre-react dyan na galing sa ating lupa, which is the bearing force. Okay? So, of course, kapag nagde-design tayo, we have to compute for the bearing capacity of the soil. Okay? So, this bearing capacity solely relies on the area of the end bearing piles. Okay? Okay? So, sa next naman na structural behavior is we have the friction piles. If strata is at large depth, it transfer the loads from the structure to the soil layer by bits of friction. So, kapag yung ating hard strata or hard soil is at a much greater depth, so gagamit na tayo ng friction piles. So, paano naman yung friction piles? Since hindi siya naaabot sa strata, ang gagamitin lang natin is the friction of the soil around these piles. Okay? So, siya na yung kukontra sa load na bigay ng ating structure. So, paano naman natin ngayon i-increase ang frictional capacity ng ating pile? So, to increase the friction capacity of the pile, we have to also increase the roughness of the pile since nagre-rely yan sa the friction between the surface of the pile and the surrounding soils. So, increasing the roughness of the pile, increasing the diameter, increasing the pile length, and of course, increasing the number of piles. Okay? Next, we also have the types of pile foundation based on construction methods. So, there are two types of this construction method. The first one, sa left side natin, we have the driven piles. So, sa driven piles, kung makikita nyo, para siyang kung i-relate nyo sa ibang bagay, para siyang pako. Okay? So, yung pile natin ay pinapako or pinupukpok, hinahammer papunta sa ating underneath ng ating ground. So, ibig sabihin lang nun, this pile is either hammered or vibrated sa ating ground surface. Okay? So, sa ating next na construction method naman, we have the bored piles or the drilled piles. So, simple lang naman yan. As you can see from the figure, ang unang ginagawa dyan is to drill a hole wherein after nyan, ilalagay natin yung ating reinforcement, saka bubuhusan ng fresh concrete. So, yun na yung magsaserve na ating piles. Okay? So, yun lang for the construction method sa pile foundation. Okay? So, next naman, we have, ayan, so, okay, let's now proceed to the determination of pile capacity since na-discuss natin yung different types of behavior and the different types of construction method that is used for the pile foundation. So, ayan, the pile capacity or the static pile analysis. So, for the ultimate bearing load of pile, simple lang na equation. We have QU is equal to QEB plus QSF. So, i-discuss ko yan mamaya as we go further sa ating discussion. So, may figure mamaya. So for the allowable bearing capacity of pile naman, simple lang ulit. We have the Q allowable is equal to QU over the factor of safety. Okay? So where the QU is the ultimate bearing load of the pile, QEB is the ultimate end bearing resistance of the pile, QSF is the ultimate skin friction resistance of the pile. Ay, hindi ko na drawing wala. So yan, drawing ko na lang. So dito, meron tayong pilote and pile. And then, of course, meron tayong structural load sa taas. So, yung equation ng ultimate bearing pile, simple lang. We have the Q sub EB. Ito yung Q sub EB. And bearing capacity. Okay? Ito lang yan. So, the end bearing capacity. Of course, meron din tayong magre-resist dyan na skin friction capacity. Ayan. Yan yung SF. Okay? Simple lang. So, for allowable, alam nyo naman na siguro yan, that factor of safety is equal to the ultimate over the allowable. So, equating for the allowable bearing capacity, you will arrive with this formula. Okay? So, now, dito meron tayong piles on sand and piles on clay. So, bago tayo mag-proceed, buruin ko muna to. Okay? So, yung una is we have the piles on sand. Again, we have also the end bearing resistance of pile on sand denoted by this equation. The QEB or the end bearing pile is equal to PV times AP times NQ, where PV is the effective vertical stress at critical depth, AP is the area of the pile tip, NQ is the bearing capacity factor. Again, ilagay ko ng lahat ng formula dito. Explain ko na lang. So, skin friction resistance of pile on sand is denoted by this equation. QSF is equal to mu times P times A PV diagram times K. So, meron naman na siguro dyan. Kindly read on that one na lang. Ayan. Ito yung figure na yan. So, itong Q-tip, same lang din yan sa end bearing pile. Yan nga. So, kapag kumuha tayo dyan ng area, ito yan. Yan yung makikita natin. So, solving for this end bearing pile, meron tayong equation na PV, AP, and Q. So, kung gusto nyo mag-memorize, pwede naman to, okay? Pan, Q, kung gusto nyo ng mnemonics, or simply pan, okay? So, sa next naman, we have the skin friction capacity. So, ito yon sa side, tawag dito, sa ating skin ng ating pile and the soil, okay? Sa our sand. Also, it is denoted also by this formula. QSF is equal to mu P APVK. So, pwede nyong i-memorize yan using this mnemonics. Pac mu, okay? Or sige, parang bastos yun na. Upak na lang, upak. Para hindi bastos, okay? So, kayo na bahala doon kung anong memorize nyo, okay? So, ano nga ba ibig sabihin nitong critical depth na yan? So, malalaman nyo mamaya. So, specifically pala, this piles on sand depends solely for two types. Okay? Na hindi na nakita. We have the dense sand and the loose sand. So, sa pag-measure ng critical depth natin, from the top sand of the sand layer, kapag daw dense sand, ang ating critical depth is 20 times the diameter of the pile. So, kapag loose sand naman daw, it is only 10 times the diameter of the pile. So, laging tatandaan that this is a vertical na measurement. Okay? So, from the top sand of the sand layer, papunta sa kung saan man siya mag-end. So, yun yung critical depth natin. So note nyo na kapag sa distance ng ating critical depth, ang ating pressure diagram will be varying load o varying pressure, okay? So ibig sabihin lang nun, okay, draw natin. Ito example. So yan. Kunwari, this is our critical depth. Therefore, yung ating pressure diagram will look like this. Okay? So, ito yung pressure diagram natin. Varying siya. So, from the top sand of the clay layer, papunta dito, sa ating critical depth, varying load siya. So, after naman nung critical depth natin, ang ating pressure diagram will be uniform. So, yun naman kagandaan niya. So, kapag from the start ng ating critical depth, papunta sa end ng critical depth, ang pressure diagram natin dyan will be varying load. Okay, varying pressure. Okay, so kapag naman sa after ng critical depth, uniform na yung ating pressure diagram. So, yun lang yan for piles on sand. So, proceed naman tayo sa piles on clay. Okay, so solving for the end bearing resistance of pile on clay. We have, so ganun pa rin yung ating ultimate na ultimate bearing capacity. QEB plus QSK pa rin or SF. Okay? So, end bearing capacity resistance of pile on clay, it is given by this equation, C times AP times NC. So, again, kapag gumawa kayo ng mnemonics, cup na lang yan. Okay? Para mapadali kayo. So, where C is the cohesion of the pile tip, A is the area of the pile tip, NC is the bearing capacity factor. So, paano naman kapag meron tayong 3 layers of clay? Ito. Kunwari, meron tayong 3 layers. Ayan. Anong kukunin natin na cohesion dyan? Okay? So, ang kukunin natin ng cohesion dyan, kunwari ito yung 1, 2, ito yung number 3. So, ang kukunin natin ng cohesion dyan for our end bearing resistance of pile on clay is our cohesion sa layer ng kung saan nakapatong yung ating pile tip. Okay? So, kapag nandito yung ating pile tip sa soil layer 3, so yung cohesion ng soil layer 3 ang ating gagamitin for in solving our end bearing resistance of pile on clay. Okay? Ayan. So, paano naman kapag solving for resistance of pile on clay? Meron actually tatlong method dyan in solving skin resistance. We have the alpha method, the beta method, and the lambda method. So first one is the alpha method. It is given by this equation, C times L times alpha times P. So again, madali lang naman na siguro memorize yan. Clap. Ayan lang, clap. So kapag alpha method, tandaan nyo lang, clap. Okay? So again, paano naman kapag ang ating pilote ay nakapatong ulit sa 3 layers of sand or clay pala. And this is 1, this is 2, and this is 3. Okay? So, paano naman yan? Paano natin solve yung skin friction dyan? Okay? So, ganito lang yan. So, yung skin friction kasi, kasali lahat ng ating kapag skin friction, kasama yung ating ito lang yung consideration. So, lahat is makukuha kapag several layers of clay. So, kapag ganon, we can solve this skin friction lang naman if we take the summation of clap. So, yun lang. So, meron tayong skin friction sa soil layer 1, skin friction sa soil layer 2, and skin friction sa layer 3. So, kapag alpha method, ang gagamitin nyo lang is clap. Okay, tandaan yan. Clap. Alpha method, clap. Okay. So, proceed naman tayo sa next na method. We have the beta method. Kapag beta method naman, we have beta times L times sigma prime M times P. So, ayun. Sabihin nyo na lang this is kapag gusto nyo mag-mnemonics to memorize this easier, di block. So, kayo na bahala dyan. Okay? So, this is the formula for alpha method. Wala nga ta. Hindi ko nalagay yun lang. Hindi ko nalagay. So, lagay ko na lang siguro. Lang. So, sa beta method, we have ways to compute the beta. Yan, lagay ko dito. So, beta. Kapag normally consolidated clay siya, we have this formula 1 minus sine phi times tangent phi. So, kapag naman overly consolidated clay tayo, simply, ito yung formula. Tan phi times the square root of OCR. Okay? So, yan yung beta method for skin resistance sa pile. So, paano naman kapag lambda method? So, ewan ko na lang kung paano gawan ng mnemonics to. So, kayo na bahala. And, lambda times L times sigma prime M plus 2C times P. So, ayan. So, andito naman na indicated yung mga legends niya. So, kapag C ay cohesion, the L is the length of pile, P is the perimeter of the pile section, sigma prime M is the vertical effective stress at mid-height of the clay layer. So, tandaan nyo yan, mid-height. Yan, naka-M naman. So, mid-height. Alpha is the adhesion factor or the frictional constant, and B is the skin factor. And lambda is the effective frictional factor. Ayan. Hindi ko na napura. I'm sorry. Wrong time muna. Hindi ko lang edit. So, ayan. So, paano naman kapag yung ating pile ay nag-act as group? Or group. Group lang. So, kung gagamit tayo ng group of piles, it is important that we have to create a pile cap. So, ito yung pile cap natin. Okay? So, yan. So, kapag group of piles tayo, it is important that we have this so-called pile cap. So, sa pag-determine ng bearing capacity of group of piles is very komplikado talaga and still unresolved. Now, kapag yung piles natin are spaced closely to each other, may tendency talaga na mag-overlap yung stresses that these piles receive and transfer to the soil. Okay, so kung makikita nyo kung sakali, kunwari ito yung ayan. So, kapag nag-overlap yung area na sinasakop nitong stresses na to from the group of piles papunta sa soil, so meron talagang reduction of load-bearing capacity of the piles. So, since may reduction na dito, so dyan napapasok yung ating tinatawag na efficiency. So, meron tayong formula dyan for efficiencies. So, pile capacity group for group action, we have the equation of converse Labar. We have efficiency is equal to 1 minus theta times m minus 1 times n plus n minus 1 times m over 90 mn. So, meron tayong second equation din by Bowles equation that the efficiency is equal to, so basahin nyo na lang siguro. So, based on allowable block and allowable individual capacity, meron din tayong efficiency, that the all block over all individual. So where the EG is the efficiency, M is the number of columns, N is the number of rows, D is the diameter of the pile, S is spacing of piles center to center, tandaan niya, center to center, tan phi or D over S is in degree. So Q all block, combined capacity of group piles, Q all individual, sum of capacities of individual piles. So tandaan niyo yung formula dyan. Okay. So, binigay rin yung equation for the ultimate capacity, assuming that the piles in group act as a block. So, memorize nyo na lang siguro yan. Ayan sobrahan. Okay, memorize nyo na lang siguro yan. Pause nyo and take note na lang siguro. Okay, so, ayun for the introduction lang and the formulas na gagamitin natin sa topic na to. So, let's start on solving problems regarding this topic para mas maintindihan nyo mismo yung lecture natin or yung subject na to. Okay? So, ayan. For situation 1, a circular pile is 0.40 meters diameter and 12 meters long is embedded in a layer of dense sand. The soil has the following properties. Dry unit weight is 18 kilonewton per meter cube and saturated unit weight is 20 kilonewton meter cube. Water table is located 4 meters depth from the ground surface. NQ is equal to 80, K is equal to 1.2, mu is equal to 0.4, and Fs is equal to 3.0. So, first question natin is to compute the point bearing capacity of the pile. So, kapag i-illustrate ko yan, ganito to. So, ito na yan. Okay? Kulang pa pala. Ano kung kulang na diameter? Ito, diameter of pile. So, this should be 0.40. Okay? So, paano natin simulan yan? So, alamin nyo muna kung Diyos ko, nabura pa. So, wait lang. Ulitin ko na lang ulit. At, boom! Ayan na siya ulit. So, okay. So, before we start, syempre alamin nyo muna yung kung ano ba yung soil natin dyan or anong type of soil. So, nakalagay naman siguro dyan that this problem is dense sand. So, paano ulit kapag dense sand? Ang critical depth kapag dense sand, ang critical depth natin is 20 times the diameter of the pile. Okay? So, 20 times 0.4, it is equal to 8 meters. So, yung critical depth ng ating pile, so, galing siya sa top of the sand layer. So, galing dito, papuntang 8 meters from the top of the sand layer. So, from the top sand of the clay layer, papunta sa critical depth, diba nga, 8 meters daw yan. So, ano ulit ang ating pressure diagram kapag nandun tayo sa critical depth, siya ay varying. So, from dito sa soil layer na to, na dry, of course, kukunin natin na agad yung so, kapag kinuha natin yung vertical stress yan, so, ganun ulit gagawin natin, it's just the unit weight times the height. So, dito sa layer na to, is just 18 times 4. So, it is equal to 72 kilopascal. Okay? Hindi siya dyan. So, sa baba siya, dito siya part. Yan yung effective stress dyan. So, hindi ko na may sulat. So, next naman, sa soil layer na to, since varying pa rin yan, ganyan yan. Papunta sa end nung critical depth. Okay? So, kapag sinolve natin yung effective vertical stress dyan, we have 18 times 4 dito sa from the top so 18. So 18 and 18 times 4 plus 20. Okay, saturated siya. So gagawin natin effective. So 20 minus 9.81 times kung ilan ang natira dito. Okay? So since 4 to, therefore 4 din to. So 20 minus 9.81 times 4. So ang sagot ngayon natin dyan is 112.76 kilo Pascal. So yan na ngayon yung magiging pressure diagram sa ating critical depth. So after naman ng ating critical depth, sabi nga natin that the pressure diagram will only be uniform. So since uniform yan, therefore this pressure here is just the same, di ba? 112.76 kilo Pascal. Okay? So we can compute now for the question number 1, the point bearing capacity of the pile. So meron tayong formula dyan. Payo ko ng blue. QEB is just equal to, kung maalala nyo, PAN. Yung P dyan is the effective stress. So, yung effective stress na yan ay kukunin lang natin sa tip of the pile. So, yung stress sa tip of the pile will be this effective stress. So, ang gagamitin natin na effective stress dyan is 112.76. So, yung area naman of the pile, since may given naman dyan na 0.40 diameters, we have pi over 4 times 0.40 squared. Tapos, so, ito pala guys. Ang NQ natin is given by 80. So, kapag kinompute nyo, dyan sa mga upuan nyo, the answer will be 113 point, okay, 1133.587 kilo Newton. So, check natin. Nabura ko na naman lahat. So, ayan, check na lang natin kung tama ba yung sagot natin. And so, tama naman yung sagot natin. Therefore, tama yung process na ginawa natin. So, for the next question, we have compute the frictional capacity of the pile. Again, meron naman tayong formula dyan na binigay. It's just SF is equal to pak mu or upak. Upak na lang gamitin natin. Pak. Okay? So, since kanina, sa figure natin, meron tayong several layers of pile. Therefore, ang kukunin natin is the summation of mu pak sa ating different layers. So, solve natin. We have sa mu, given naman siguro, which is 0.4. Ang perimeter natin hindi naman nagbago sa both na layer. Therefore, ang perimeter ng ating circular pile is just pi times the diameter. So, pi times 0.4. Next, for the yung area dito is just the area under the pressure diagram. So, A is the area under the pressure diagram. So, we have for the first, sulat ko muna siguro yung area under the yung vertical stress sa area sa layer natin kanina. So, sa PV1, we have 78 kilopascal. So, ano na lang, mag-back na lang kayo siguro para makita nyo yung process kanina kung paano nakuha yung PV1 sa PV2. Okay? 112.76 sa soil layer 2. So, ayan. So, sa layer 1, we have triangular yon or varying. Therefore, ang formula natin dyan is 1/2 base times height. So, ang base natin is 4. Ang height natin is yung pressure diagram, which is 72. 78. Ayan. Next naman sa layer 2, we have 1/2. Varying ulit yan, 72. Plus the height sa pangalawa, which is 112.76, ito, times yung base natin, which is 4. So next naman sa dulo, we have a uniform load, rectangle lang din naman yan. So base times height. So yung height natin is 112.76 times yung height natin, which is 4. Okay, so meron pa tayong nakalimutan na K pala. So yung K natin given naman dyan, which is 1.2. Okay, so therefore we can solve for the frictional capacity of the pile, which is 581.809. So ayan yung ating final answer. So kapag gusto nyo i-check naman siguro, next slide ko na lang. So mabubura yan. So kindly take note. Okay. So tama yung ating sagot, which is 581.809. So for the last question na siguro to. So compute the allowable capacity of the pile. So di ba nga may formula ulit yan, which is Q allowable is equal to the Q ultimate over the factor of safety. Since meron tayong formula, meron tayong Fs na, ang QU na lang yung problema natin. But ang QU is meron ulit na formula, QEB plus QSF, kung maalala nyo, over Fs. So since meron naman na yung EB at SF, therefore we can compute for the allowable capacity of pile. Very basic na lang, di ba? So 1133.587 plus 581.809 all over 3.0. Therefore, nakita agad. So 571.799 kilonewton. So na-skip ko agad. So ito na yung sagot. Okay? 571.799 kilonewton. So these are the answer for situation number 1. Now for our second question, let's have this problem. A 0.5 meter square pre-stressed concrete pile is to be driven in a clay soil as shown. The design capacity of the pile is 652 Newton with a factor of safety equals to 2.5. The soil has a unit weight of 18.5 kN per meter cube and an unconfined compressive stress of 150 kilopascal. So for our question number 4, compute the point bearing capacity of the pile. So since ang problem dyan ay in a clay soil, yung formula natin for end bearing capacity pile will be CAN, diba? Cohesion times the area of the tip ng pile times the bearing capacity factor. Okay, so paano, since may binigay naman na QE dyan, alam naman natin from the triaxial test that when dealing with unconfined compressive stress, wala tayong chamber pressure or confining pressure. Therefore, ang minor stress natin is equal to 0 and yung major stress natin will be our unconfined compressive stress na QU.
And grabe naman sus. So ulitin ko na lang. 10. So ayan. Ito yung QU natin. Diba? Kapag clay soil naman ang pinag-uusapan, ang ating angle of internal friction is equal to 0. Therefore, yung ating total failure envelope will look like this. Ito yan. Okay? So, kapag ang hinahanap naman is cohesion, di ba? Ito lang yan. Ito yung cohesion natin or grade cohesion. Therefore, solving for the cohesion, it is only the 1/2 of the diameter na QU. Kasi ang cohesion dito sa unconfined compressive stress is our radius lang yan. Therefore, cohesion is just 1/2 of QU. Okay? So, solving for the end bearing capacity of the pile, we have 1/2 of QU, since given naman ng QU na 150, times the area of the pile tip. So, ang area ng pile tip natin is 0.5 times 0.5. Okay? And since hindi given yung NC natin, so note natin kapag clay soil tayo, kapag walang binigay na bearing capacity factor na NC, ang gagamitin natin is 9. Okay? Note nyo yan. Therefore, our point bearing capacity of the pile will be equal to 168.75. So, check natin kung tama. Yan. So, our answer is correct. Okay. So, yan yung solution for question number 4. So, next. For our next question, we have compute the frictional capacity of the pile. So, paano naman kaya yan? Okay? Since walang binigay na alpha or kahit naman dyan, you have to utilize those given. So, meron tayong hindi pa na nagagamit na design capacity of the pile. So, when we talk about the design capacity of the pile, yan yung mismong Q allowable na, okay? So, to solve for Q allowable, di ba nga, QU over Fs. Meron tayong Fs. And sa QU, ang formula niyan is EB plus SF. So, ang kulang na lang siguro dito sa equation natin is SF. Therefore, masasolve natin yung question number 5. So, yung allowable or the design capacity of the pile is 650 is equal to QEB, which is 168.75 plus QSF or the frictional capacity of the pile over the factor of safety, which is 2.5. Our answer will be 1456.25 kilonewton. Okay? So, check natin yung tama. And so, tama naman. Therefore, that is the correct answer. So, for our next problem naman, we have compute the length of the pile if alpha is equal to 0.78. So, i-compute na natin tong length na to. So, may binigay naman na alpha, which is 0.78. Therefore, we have to utilize this given na addition factor. So, ano nga bang formula ang ginagamit ng addition factor? Di ba nga yung ating frictional capacity? That is, USF is equal to clap, di ba? And, therefore, solving for the length, ito, makukuha natin siya since meron tayong cohesion, addition factor, and our perimeter. And meron na rin tayong frictional capacity. So, our frictional capacity is 1456.25 is equal to our cohesion, which is 1/2 of 150 times the length na hinahanap times yung given na addition factor and our perimeter, which is Since square lang yan, we have 4 times its side, di ba? So 4 times 0.5 meters. Therefore, our length is equal to 12.447 meters, or kung magde-design tayo, lalakayan na lang natin siya since pangit naman siguro tignan ng 13 meters, pero pwede lang depending sa choices if kung anong closest sa ating acquired na length. So yun na yung magiging sagot natin. So ang length natin can be 13 meters, 14 meters. So yung length natin must be greater. Okay? So whole number siya. So either kung ano mas malapit sa choices, yun ang ilalagay natin. Okay? Checking for our answer. So 14 meters. Nakuha ba? Nakuha yan. So, let's proceed to our next question. Buray ko na ito. So, for situation 3, a 0.5 meters diameter precast concrete pile is to be driven in a clay soil profile as shown. So, ito daw yan. Ayan. So, meron tayong 2 layers. Okay. So, and now, for the 7th question, compute the point bearing capacity of pile. Then again, ang soil natin dito is clay soil. Solving for the end bearing capacity, chicken joy na lang yan, di ba? Very easy. Okay? We have C, A, and silang ulit yan. So, ano ang consider natin dito na layer? So, ano yung gagamitin natin na cohesion? Again, when we talk about point bearing capacity of the pile, ang i-consider natin is yung ating pile tip. Kasi nga, end bearing capacity of the pile, di ba? So, yung end yung i-consider natin. Okay? So, ang cohesion dyan is 1/2 of 160 times yung area of the pile tip, which is may binigay naman na diameter, pi over 4 times 0.50 squared times the bearing capacity factor, pag hindi binigay, 9 siya. Okay. So, our end bearing capacity or our point bearing capacity is equal to 141.372 kilonewton. Okay? Nakuha? Nakuha. Solve nyo lang siguro yan. Checking our answer kung tama ba. So, 141.372 kilonewton dapat yan. Okay? So, answer should be kilonewton. Tama ba? This should be kilonewton. Next, for our question number 8, compute the frictional capacity of pile using the alpha, beta, and lambda method. So, mahaba-haba to. Therefore, sa first na method natin, I'm going to use alpha method. So, sa alpha method natin, we have alpha method. Consider alpha method. Since there are several layers of clay, we have to use the summation of CL alpha P. So, clap for frictional capacity. Therefore, solving QSF, sa first layer, ang cohesion natin dyan is 1/2 of 100 times yung length natin, which is ito, papunta dito is 10 meters, and our alpha is given 0.60 times the perimeter, which is pi times the diameter. So, yan pa lang yung soil layer A. So, meron pa tayong frictional capacity sa soil layer B, which is 1/2, ang cohesion niya is 1/2 of QU 160, and the length is, since 25 meters to, therefore, ito is 15 meters. So, 15 meters sa soil layer A, and ang alpha natin dito is 0.40. Again, yung perimeter, ganun pa rin, pi times the diameter. Therefore, calculating, ang makukuha yung sagot dyan should be 1225.21 kilo Newton. Okay? Check natin kung tama. So, sa first part, ito, 1125.21 kN. Next naman, sa beta method, suburahin ko na ito ha. So, 1125 for our alpha method. Sulat ko lang ulit. Alpha is equal to wait lang. QSF for alpha method is equal to 1225.21 kN. Next naman, we're going to use the beta method. Okay? So, meron tayong formula dyan, which is Blump ba yan? So, beta times length times sigma prime m times p. But, dito sa figure natin, wala tayong beta. But, we can solve the beta since given naman yung angle of internal friction. So, solving for beta, for soil layer A, we have sine, 1 minus sine ito. So, meron siya angle of internal friction na 20 times tangent of 20. Therefore, our beta 1 is equal to 0.239. Okay? Solving naman for beta 2, soil layer B, 1 minus sine, ito, angle of internal friction na 22, tangent of 22. So, our beta 2 will be equal to 0.253. Okay? So, now we can solve for the frictional capacity using beta method. May kulang ba? We also have to solve for the sigma prime m. So, ano nga ba yung sigma prime m ulit? Sigma prime m is the effective stress at the middle of the clay layer. Therefore, isosolve natin yung effective stress sa gitna lang ng ating mga layer. So, considering soil layer A, gitna niya is, ito, 7.5 meters. Okay, so, ganun lang ulit yan. Unit weight times the height. So, 16.5 times 7.5. Ang ating sigma prime m for the layer 1 is 82.5 kilopascal. Solving naman our sigma prime MB, or considering layer B, we have from this topsoil plus itong gitna ng layer B, which is kalahati ng 15 meters, we have 7.5 meters. Therefore, from the top layer, 16.5, ito, sa layer A times 10, plus, since saturated yan, ang kailangan natin is effective unit weight, 20.7 minus 9.81 times yung kalahati niya na kalahati ng 15, so 7.5. Ang sigma prime MB natin, or considering layer B, is equal to 246.675 kilopascal. Okay, kompleto na tayo. Now, we can solve for the frictional capacity of pile using beta method. Okay, so sa first layer, beta 1, which is 0.239. Ang length niya, soil layer A is 10. Ang sigma prime m niya sa soil layer A is 82.5. Ang perimeter niya is ganun pa rin, pi times the diameter, pi times 0.50. And for soil layer B, ang beta 2 niya is 0.253 times its total length, which is 15 meters, times the sigma prime MB, 246.675 kilopascal, and our perimeter, pi times d. Therefore, ang ating QSF considering beta method is equal to 1780.194 kilonewton. Okay, haba. And then, ayan, checking natin dito. So, 1780.194 kilonewton. So, tama yung sagot natin. Lagay ko lang ulit dyan sa summary. Suburin ko na to. And now, for the last method, which is the lambda method, the formula for QSF for beta method is ito. Lambda L sigma prime M plus 2C times P. So, given naman na lahat siguro yan. So, since several layers, yan, kukunin natin yung summation nyo lang. Okay? Given naman yung lambda for soil layer A, 0.10 times yung length niya, which is 10 times sigma prime M sa soil layer A is 82.5 plus 2 times yung cohesion niya, which is kalahati ng 150 times perimeter, which is pi d pa rin, pi times 0.5. Again, kukunin din natin yung frictional capacity sa soil layer B. Sa soil layer B, we have given naman na lambda, which is 0.14 times yung length niya times sigma prime M, which is nakuha kanina na 246.675 plus 2 times kalahati na itong QU na to, yun yung ating cohesion, therefore kalahati ng 160 is 80, and we have the perimeter na pi times the diameter. So ang makakuha nyo sagat dyan should be equal to 1628.158 kilo. So, check nyo na lang kung tama yung mga na-input kong dyang datas or results. Okay? Or yung mga na-solve natin, computation. So, summary lang, lalagay ko na lang din ulit dito. And, bang! Meron na yung mga sagot natin for different kind of methods. Check natin kung tama yung masagot natin. Ayan. So, hindi ko makita. So, tama naman yan. Ako ginawa yan eh. So, kindly check on that one na lang, okay? So, for our next problem, gawin ko lang to. Compute the design capacity of the pile if our factor of safety is equal to 2.5. So, ang gagamitin ko lang dito, design capacity, di ba yan yung ating Q allowable. Again, given naman na yung formula niyan, na Fs, na QU over Ff. So, ang gagamitin ko lang na QU dito is in terms of alpha. Kayo na lang maghanap ng allowable capacity in terms of the beta method and lambda method. So, ang Q SF na gagamitin ko for this problem is alpha method, okay? So, we have QU, ang formula niyan is EB plus SF. So, meron man na tayong EB, which is 141.372, plus yung SF natin for alpha method is 1225.21 all over the factor of safety na binigay na 2.5. Ang makukuha natin sagot dyan for the design capacity or the allowable capacity of the pile will be equal to 546.637 kilonewton. Very basic. Check natin kung tama. 546.637. Okay, very basic, no? Now, for our next problem, we will be dealing with a drilled pile. So yung mga previous problem natin was driven pile. So ito na is drilled pile, right? So that should be drilled. A drilled pile shown in the figure has a bell diameter dB 1.5 and carries a working load of 1000 kN. The diameter of the shaft is 1.8. The board pile is drilled in a clay layer having a cohesion as shown. Addition factor is equal to 0.9. Use factor of safety of 2.8. The base of the bell is 1.8 meters below the shaft. So ito yung figure natin. Okay? So for our first problem, ang sabi dyan, compute the point bearing capacity of the pile. Again, very basic na naman yung clay soil yung ating soil. Ang formula dyan is ano ulit yan? Hans. So again, when we talk about the end bearing capacity of the pile, ang kino-consider natin dito is the pile tip, kung saan patong yung ating pile tip. So yung condition na gagamitin natin dyan is the 1/2 of QU, which is 150 times area nung considered pile tip, which has a diameter of 5 meters. So over 4 times 1.5 squared times the bearing capacity factor, since hindi given, ang gagamitin natin dyan is 9. Therefore, our end bearing capacity factor or end bearing capacity of the pile or the point bearing capacity of the pile is 1192.823 kilonewton. Okay, this is our answer for question number 10 dapat to 10. Question number 10 pa lang tayo. Okay? So for our question number 11, compute the frictional capacity of the pile. So when we talk about the frictional capacity of the pile, yan na yung QSF ulit. Again, since walang may binigay na addition factor, but there is easy way, kailangan lang natin i-maximize yung ating mga given. Since meron naman tayong given dyan na working load, again, kung hindi nyo maalala, ang working load natin, yan lang yung ating allowable capacity. Okay? So, we can make use again ng ating formula na Q allow is equal to QU over Fs. So, ang allowable natin is 1000 kN. Ang QU natin ulit is just EB plus SF. Again, meron naman na tayong EB which is 1192.82. Ang kulang or hinahanap natin is QSF, di ba? So, ang Fs natin given naman na 2.8. Then, QSF, computing, ang makukuha natin dyan is 1607.177 kilonewton. So, that is our final answer for question number 11. 167.177. For our number 12 na question, compute the length of the pile. Paano naman yan? Okay? Ito daw. Ang hinahanap natin is ito. Paano natin compute yan? Ano nga ba ang formula sa mga na-discuss natin ang merong length? Diba? Ang beta method or alpha method. Tama? May binigay ba na beta? May binigay ba na angle of internal friction? Diba wala? Diba may binigay naman na addition factor? Tama ba? Tama. So, for drilled piles pala, mag-take note kayo that the alpha is equal to 0 for the top 1.5 meters and 1 diameter ds above the bottom of the shaft. Ano ibig sabihin nun? So, yung alpha daw natin is 0 kapag from the top papunta sa bottom na 1.5, ibig sabihin top 1.5 meters. So ito 1.5 meters ang ito pa yung kulay. So 1.5 meters. Ang ating alpha dyan is equal to 0. Ang next naman na sinabi is 1 diameter ds above the bottom of the shaft. So ano ang diameter ba ng ds natin or diameter of the shaft? Given siya as 0.8. Therefore, ito yung bottom ng shaft natin. Di ba? Ito yung shaft. Ayan yung shaft natin. Ito yung bell. Okay? So, yung bottom daw ng shaft natin, 1 diameter above ng bottom of the shaft. Di ba ang 1 diameter natin is 0.8. So, ang alpha daw dito is equal to 0. Okay? So, for drilled piles, again, alpha is equal to 0 from the top, 1.5 below the top, and 1 diameter below the bottom of the shaft, pataas is equal to, ang ating alpha is equal to 0. Okay? So, ilagay ko dito yung formula for skin frictional capacity, which is clap, di ba? Considering sa may several layers tayo, therefore, summation of clap. So, ano nga ba lang yung magagamit natin na layer dyan? Since 0 naman tong ating alpha dito sa layer na to, itong layer na yan, hindi natin magagamit yan. And also for this. Kasi kapag tinimes natin yan, 0 times yung buong CLAP na yan, magiging 0 lang yung layer na yan. Okay? So, ayan. So, ang gagamitin lang natin for solving skin frictional capacity is itong layer na to and itong layer na to. Okay? So, before itong layer na to, so layer C is din na may gamit yan. Ang consider lang natin na length of the pile, ito lang naman, di ba meron? Okay? So, ang consider lang natin dyan is ito. Okay? Hindi natin consider yung bell. Ang consider lang natin dyan is the shaft. Okay? Next. So, paano nga ba natin makuha yan? Di ba, hindi given yung ating length of the pile. So, hindi rin given to. So, I can name this as X. Okay? Therefore, itong length na to is X minus 1.5. Tama? X minus 1.5. So, sa length naman na to, sa layer B, we have 3 minus 0.8 which is 2.2 meters. Okay? Kompleto na. Okay, solve natin. For soil layer A muna tayo. So, ito considering yung itong part na to. Okay? So, ang cohesion dyan is 1/2 of 60 times yung length which is X minus 1.5 meters. The adhesion, may binigay dito which is, so yung natitira dyan na hindi alpha is equal to 0, ang alpha natin dyan is 0.9. So, perimeter, it's just the pi times the diameter of the shaft, 0.8. So, layer A, layer A pa lang yan ha. And next is itong layer na to. Okay, we have 1/2 times yung consider natin na cohesion is 1/2 of 100 times yung length niya is 2.2 meters times the addition factor na 0.9 times the perimeter. So, okay, wala pa tayong QSF. Meron na pala, ito. Dali ko lang dyan, kinulang. 1607.177. So, mag-shift solve na lang kayo. Makuha nyo dyan na X ay equal to, solve ko. 21.518 meters. So, hindi pa to yung sagot. Kasi ang tinatanong is length of the pile. Di ba nga yung X is just a part of the length of the pile? Therefore, ang length of the pile is equal to X plus 3 meters. Okay? Therefore, length is equal to 21.518 plus 3. Ang length natin is equal to 24.518 meters. Or equal to, kapag binuo natin yan, 25 meters. Or greater than that. So, kapag multiple choice, ang gagamitin, ang pipiliin niya lang is yung closer sa ating sagot. Okay? Ayan. So, naintindihan naman siguro pag drilled piles. Take note nyo ulit that 1.5 meters from the top papunta sa pababa na 1.5 meters, 0 ang ating alpha. And from the bottom of the shaft, 1 diameter pataas ay 0 din yung ating alpha. Okay? Yun lang. So, for the last problem, we're going to deal with group of piles. Okay? Babasahin ko muna. A pile group consists of 12 piles with a diameter of 0.40 meters and a pile length of 10 meters. The piles are spaced in 3 pile by 4 pile rectangular matrix configuration. The piles are driven to the clay that has the following characteristics according to a borehole data. Center to center spacing is 0.9. Okay? So, ito yung figure na natin. Ito. So, for our question to 9, 10, 11, 12, 13 question to 13. Determine the allowable load in the pile group considering that the piles act individually. Use factor of safety of 2.5. 2.5 lang. Yun lang. Wala pa lang unit yun. Okay? So, ang tinatanong dyan is allowable. So, ano nga ba ulit yung formula for allowable? QU over S. So, ang given lang dyan sa problem na yan is our FS. Okay, so, kailangan natin i-solve yung QU. Sulat ko lang. QU. So, QU is just QE B plus QSF over S. So, ang ating isa-solve dyan is QEB. Considering that it is into a clay, then yung formula dyan is fancy. Then again, kapag nag-compute tayo ng end bearing capacity factor, end bearing capacity of the pile, ang consider natin is the pile depth. So, dito muna i-solve natin sila individually or isa-isang pile. So, CNC, ang gagamitin natin cohesion dyan, given naman na 120 times the area of the pile, yung tip ng pile, which is just equal to, may diameter siya na 0.4 times 0.4 squared. And the bearing capacity factors hindi binigay, gamit lang natin is naman. So, end bearing capacity natin dito will be equal to 135.717 kilo newton. Okay? So, end bearing capacity pa lang yan. Next, meron tayong skin friction. Since meron tayong several layer, and take note nyo ulit to. Kapag we are working on group of piles, alpha method is commonly used. So, if alpha is not given, therefore, ang alpha natin for group of piles is 1. Okay? Tandaan yan. Kapag hindi given yung alpha natin for group of pile action, ang gagawin is 1.0. Okay? So, gamitin natin yung alpha method, which is CLAP. Since may several layer tayo, kailangan natin mag-summation. So, for soil layer 1, ito. This is 4 meters, this is 4 meters, and this is 2 meters. Okay? So, cohesion for soil layer 1 is 40 times its length is 40 rin. Ang addition natin is 1.0. Ang perimeter natin is pi times 0.4. Soil layer 1 pa lang yan. Next, soil layer 2, cohesion is 75 The length, bakit 40 to? It should be 4 meters. Next, 4 meters ulit to. 1.0 ang kanyang alpha. And the perimeter is just pi times the diameter. Next, for soil layer 3, we have cohesion of 120, a length of 2, a addition factor of 1, and the perimeter, which is pi times the diameter. So, ang makukuha niyong SF dyan should be equal to 879.646 kilonewton. Okay? Sabay na natin isolve yung Q allowable. Okay? Again, QEB. Meron tayong QEB. 135.717 plus 879.646 all over 2.5. Sobrang kamas. Therefore, RQ allowable kapag kinonsider natin daw na individual na sila, kasi individual pa lang to. Ang kailangan natin is nag-act na sila as individually. So therefore, ita-times natin siya sa number of piles. Tama? Kasi consider natin siya as individual na pile lang. Or, ayan, act individually. Ayan. So therefore, Q allow individually is equal to 4873.742 kilonewton. Okay? So this is our answer for question number 13. For our next question naman, we have determine the allowable load of the piles considering group action using Bowles proposed equation. May binigay naman ako na formula kanina for Bowles proposed equation. Kayo na bahala kung paano nyo i-memorize. Mali. N plus N minus 2 times S plus 4D over 5DN. So, given naman natin siguro yan, we have 2 times the number of rows and number of columns. Hindi naman nakasiguro kan magkakamali dyan. Either 3 or 4. Pag balik ta rin naman, yun pa rin naman yan. So, 3 plus 4 minus 2. O kahit magbaliktad dyan, ayos lang. Ang naman magbabago dyan. And our center to center spacing na S is 0.9 plus 4 times the diameter. This is 0.4 over pi times the diameter 0.4 times the times mm. So, hindi na kayo magkakamali dyan. EG or the efficiency according to Bowles equation is 70.29%. Okay? So this is not the final answer pa. Ang tinatanong is determine the allowable load on piles considering group action using Bowles proposed equation. So when we talk about the allowable load, so ang gagawin lang natin is to multiply this efficiency to our allowable load na individual piles lang na walang efficiency factor. Okay? Allow is equal to 4873.742 times 70.29%. Our Q allowable, considering Bowles equation, is 342.75 5.753 kilonewton. Okay? So this is our answer for question number, ano ba to? Question number 13 natin ito. 14. Okay. Ayan. So, for our question number 15, compute the ultimate capacity if the piles in the group act as a block. Ano naman yan? So, yung pile down natin, yung group of piles na to, is mag-act as a block. So, ano yan? So, ayan, ilipat ko lang para mag-drawing ko. Kapag daw yung piles natin is nag-act as a block, ano ulit yung block? Di ba rectangular or square block lang yan? So, drawing ko muna. So, ito na yung figure natin from the top view. So, ang question dun sa number 15 is, paano na kapag yung group of piles na to is nag-act na as a block? Ibig sabihin, ay magiging ganito siya. Ang consider natin is from end to end. So, magiging rectangular block na siya. Okay? So, itong length na to, this is what we call the LG. Okay? So, yung LG na yan is just 0.9 plus 0.9 plus 0.9 and yung kalahati ng ating diameter. Tama? Diameter ng ating pile. So, therefore, tig-kalahati. Ito, saka ito. Plus 0.4 over 2 plus 0.4 over 2 is equal to hindi na kasi nakapito. 3.1 meters. 3.1 meters. Next naman, for this part na to, we have end to end ulit. Itong end na to, papunta sa end na to. So, yan yung tinatawag natin na PG naman. Okay? So, we have 0.9 plus 0.9 plus kalahati, tig-kalahati ng dalawa, 0.4 plus 0.4 over 2. We have BG is equal to 2.2 meters. Okay, sabihin natin yung mga dimension ng ating piles kapag consider natin siya as a block. So, BG and LG is equal to 3.1 and 2.2. So, balik tayo dun sa board natin. Ayan. So, computing now, mas madali na. Ultimate capacity na QU. Ano natin ito naman? Ay, nakita natin yung sagot. So, QU is equal to QEB plus QSF. Okay? And solve muna natin yung QEB. So, pwede nyo sundin yung formula na 2 alpha CL times LG plus BG. Okay? So, pwede lang sundin yan for group na nag-act as block, or pwede nyo gamitin din yung end bearing na lang for clay. So, same lang din makuha nito. We have Kansi. Kansi. Diba? Kansi. Okay? So, yung cohesion sa end ng soil layers, ito, 120, times yung area na nagagamitin natin, since yung area niya is, ito na yung dimension, ito na yung gagamitin natin for finding the area of this end pile. We have 2.2 times 3.1 meters times the bearing capacity factor, since in the given QEB is equal to 7365.6 kilonewton. Next naman, for our skin friction, again, since may 3-layer tayo dyan, gagamitin natin ulit yung alpha method. CL alpha P. Okay? So, for our first layer, ito, ang cohesion natin dyan is 40 times yung length niya, which is 4 meters, times yung addition factor 1.0, times yung perimeter. Perimeter ng rectangle is 2 times the length plus 2 times the width. Okay? 2 times 2.2 plus 2 times 3.1. Okay? For soil layer 1 pa lang yan, ha. So next, for soil layer 2, we have yung cohesion niya is 75 times 4 meters times 1.0 na addition factor. Ang dami natin yun, ha. 2 times 2.2 plus 2 times 3.1. So, yan pa lang soil layer 2. So, for soil layer 3, 120 times 2 meters times 1.0. And then we have its perimeter, ganun pa rin, 2.2 plus 2 times 3.1 meters. So, solving, ang makukuha natin dyan na friction capacity of the pile will be equal to 7,420 kilo Newton. So, our final answer will be equal to, kapag pinag-add nyo end bearing and friction capacity of the pile will be equal to 1475.6 kilonewton. Okay? So, nag-asa block. Next naman for our final question for this topic, number 16. What would be the minimum pile spacing to achieve 100% efficiency? So, mali na naman yung spelling ko dyan. Since ang binigay dyan is about spacing and efficiency, so gagamit natin yung binigay ni Bose, diba? So EG so EG is equal to, talagay ko na agad, alam mo na naman na siguro yung formula dyan. So EG, ang achieve natin daw should be 100%. Is equal to 2 times the number of columns plus number of rows minus 2 times the spacing natin, yun yung hinahanap, and then plus 4 times the diameter, 0.4 all over pi times the diameter times the number of rows times the number of columns, or pwedeng pabalik na rin, yun bahala. Therefore, using shift solve, ang makukuha dyan na spacing is equal to 1.35 meters. Okay? So, kung mapapansin nyo dyan, na talagang ang spacing natin between piles ay nakaka-apekto sa bearing capacity niya. Okay? So, meron tayong reduction of bearing capacity kapag yung piles natin ay closely together. Okay? So, may effect din yan kapag malalayo yung spacing natin. So, ang kailangan nyo gawin is when we talk about minimum spacing between piles, that should be 2.5 meters. Pero sa actuality, sa construction, ang ginagamit usually is for 3 meters na spacing. Okay? So, I hope that for today's lecture ay may natutunan kayo, and hasta la vista, baby.